It almost seems like there's an extra glow on there. I guess there's a light right on top of that, isn't there? That's what I'm seeing, right? It's like a highlight of some sort. I could probably turn that off, I suppose. Is it bothering, though? I'm just noticing it. Okay, well, I thought I'd start with the website since I'm right here anyway, and click into this class. And I'll at least show you a little bit around the website because you'll be referring to it frequently. This is not Blackboard, obviously, and I don't use Blackboard. It's not that I don't like it, it's just that I grew up doing my own thing, making my own website from way back when, and there's something about control when you can do everything yourself. You pay the price of having to maintain it yourself, but if Blackboard is down, I just say, oh well, I don't have to worry about it. And everything is housed on the college's web server, and I'm confident of our IT staff for the college that maintain that server. So,
IT staff.
Okay. You don't work for Sean Staples, though, do you?
I do not.
Okay. This thing, well, that color scheme error frequently pops up when I put a monitor on. Yeah, the college has its own IT staff, and it's gotten smaller. We don't maintain our own email server anymore, but we still maintain computing to a certain extent in all the labs and everything. And if you go back in time like I do, you know that way back in time, that was always the way it was. Engineering and computer science departments did everything because there really wasn't an infrastructure on a campus a long, long time ago, and we demanded all this capability, and they didn't have any reason to provide it. Who just walked in? Just so I can check you guys out. Okay. And okay. Actually, I'm still missing one person. So at any rate, when you come onto this site right now, this center section takes you into course materials, but I'm probably going to change that over to take you into the homework area automatically. But right now what you want to do, we're going to be going over this intro lecture tonight, and then, or this afternoon I mean, and we'll probably still spend some time on it on Thursday, and then we'll eventually get into chapter 2 and so on. There's no password locks on any of these lecture note files, so download them. I'm not going to hand them out. You can print them up. You can do however you want to do it. It's up to you guys. I see most everyone has the book. Mine is sitting at home right now. I forgot to bring it over. But that's definitely going to be valuable to you to have the book. The notes are very comprehensive, but the book has got the problems in it and has got additional information, because I just can't put everything in my notes, but I've got a lot of stuff in there just the same. Once we get going on things, though, if you want to, it's amazing, Microsoft can give me updates more than one a day. I did that once already today, and it's asking me to do it again. This is where all the lecture videos are. In their QuickTime, they're not streaming, contrary to what it says up here. At one time we had a streaming server, but we don't have that anymore, because we have iTunes University, which I don't like using because, believe it or not, that's not very easy to use either. To upload a video to that takes longer than it does for me to just post it on a website by a huge amount of time. But every night after class I will be at home processing my video and getting it posted probably sometime after dinner. What the plans are right now, though, is all of the lectures that you see here are from last spring, and they're all double-length lectures, because last year the class was taught one day a week. So rather than replacing every video on here, what I'm probably going to do for a time at least is keep these up on the web server so you can read ahead or see what I did if you want to. But then gradually I'll start replacing them. You know, this year I'm teaching it 2 times a week, so the video segments will be shorter. So it'll be roughly 2 to 1, but who knows how it's going to actually come out. So if you can't find what you want, rather than listing everything, I will also have, I should have a link in here, but I don't see it right now. There should be a way, I'll put a link back up on here for getting directly into the folder where the videos are, so you can just look at the dates on those files and see what's the newest one and what's one from spring 2012, for example. I don't encourage you to miss class, but the reality is some of you are going to miss class. Now, because this is a hybrid class of graduate students and undergraduates, the graduate students I full and well expect will be traveling on business and will say, I'm going to miss some time, and they're going to let me know about that. And then the videos do come in handy. I mean, it's been proven over and over again by my graduate students in the past that the videos are very helpful for people when they're traveling. Another good reason to look at the videos, though, is sometimes I will do something in MATLAB or some software of some sort, and you'll want to go back and look at exactly what I did, just simply because I don't want to take the time so you can copy down all the commands. But I get feedback that watching the video again in that section to see what the command sequence was. That won't happen right away, but there's going to be some computer projects that are going to be fairly involved, and they have my computer projects always come with a framework. So the framework consists of some MATLAB code that's the basis for what you do, and then I demo that in class with the layers that I've added, but then you might want to see how to use that framework. And the projects will be team-based too, so you'll be working more than one person on a project. Okay, problem solutions will eventually be pinned right up next to the set 1, which I've already handed out. And then quiz solutions will get posted up in here. Both of these, when I put up solutions, are going to be locked with a password. They'll be PDF files, but I'll have a password. And I have to establish that password, but I'm not going to do it on the video because that would defeat the purpose of the password. But we'll write something down before we leave today, or maybe Thursday, because I know you won't need it right away. The reason why I lock things down is I don't want to put the solutions out there just blatant like that. However, I found out last year the hard way after a big cheating scandal that solutions are out there from previous editions of the book, which really ruined the whole experience for the class in the sense that I had to stop giving homework assignments and have you turn them in. I had to switch to using quizzes because the temptation was too great. People couldn't control going out and seeing those solutions. And I guess that's a good ethics question, right? So I just skirted around it after I slapped a bunch of people up for what they did, and we moved on and I started giving quizzes. So right now, that's kind of what I'm planning on doing, just because I want to make it fair. There are honest people and then there were dishonest people, and I just want to make it clean like that. So the quizzes worked fine. So what will happen is, for at least this first assignment that you've got in your hands right now, I'll be putting up the solutions either by the end of this week or early next week. So you'll have something to look at. You'll always have something to look at before you take the quiz. And usually, the day before the quiz, I will give a strong hint like, there's 5 problems. The quiz is going to come from, say, 2 of these 5 or something. So I'll give you a pretty strong indication of where the quiz problem is going to come from. MATLAB projects, these are last year's projects. I may use them again. I may modify them. They're still posted up here. And then when we get around to having exams, I will put up old exams. I'll put up probably 2 old exams just with solutions so that you have those to look at too. And those will be PDFs again with the same password, just because. Office hours I've got posted over here tentatively as time slots before this class. Right now on Tuesdays, I've got a class that follows this, real-time digital signal processing. I don't know how I'm going to manage it exactly, but I don't have any time after this class for that reason. But on Thursdays, I will be able to be around after class. But it's going to be an evolving thing, so this is a hot link right up here. So as I tune up my schedule, you can see exactly what I'm doing. And it looks pretty intense, because that 8 to 8 is, how many hours is that? 12 hours. That's like, wow. When do I do anything else? Well, I have a lot of green space in the, this on-site research, and I'm still working on my book project that I started last fall. Hopefully I'll have that done, but I don't think it'll ever be done. I'm editing right now. Some of you know from last semester I'm writing a book called Signals and Systems for Dummies. If you've heard of the Dummies series books, I was propositioned by an agent and then who brought me into the publisher, and I'm in that process. It's been extremely challenging. I've never bought a Dummies book. I've never read a Dummies book. Probably I should have been a Dummies book user before I agreed to write a Dummies book, because it's quite an experience. The editors have been really cruel to me, I guess you'd say. I've got lots of reworks, and I'm looking forward to the book being done now. And it's a supplement book, and it uses open source software. It uses Python rather than MATLAB, and it uses Maxima rather than Mathematica. Both of those are open source. They run on all three main platforms. So I'm sort of looking to establish a new baseline for something in the future by doing that. I'll still be using MATLAB in this class, but all I can say is if you're in industry now or getting ready to go out in industry, look at Python. It's definitely for real. It's very powerful, and I almost think we should have you guys learn that instead of MATLAB, just because it's a language unto itself besides just having its scientific capabilities. Has anybody ever used SciPy and NumPy, the scientific side of Python? The language is like this. It's really long and thin. The way I look at it, it just covers all kinds of uses. It's like a universal programming language for just about anything, it seems like. And then there's the little stack up of scientific and charting and plotting capabilities that mimic MATLAB in an environment called IPython, and a set of packages called PyLab, which is very much like MATLAB. So at any rate, this will probably update some, and you'll have some sense of where I'm at. Emergent is where I've also had subcontracts, and I'm going to be working for them again this semester for a few hours at least. They do satellite communications, receivers, and compete with real-time logic, who I've also worked for, basically in competition with one another. Any questions before I get into the main flow of things here? If you are needing a refresher on MATLAB, though, I've got a whole set of notes from when we used to teach MATLAB is in place of the robotics class. Those are all open PDFs. So those are up here. I will use Mathematica a fair amount, or maybe I'll start using Maxima since I've been using that in my book, which is free, but you can get Mathematica for free, and I tend to use that for some symbolic solutions at times. But the main number crunching engine, the main simulation engine, is a MATLAB type of engine, and I'll say a little bit more about that in the opening lecture material too. What can I tell you about? Well, I'll just get into this. I'll have some more stuff I can say. So, what is it? Control L. Got to remember my shortcut keys after about a month, a little over a month not using them. So on the cover of the notes, I've got this block diagram, and this is going to be kind of our theme throughout the semester. We're going to have a message that we want to send by some means, wireless means, wired, whatever, and that gets configured in electronic form to go into the transmitter, and then it goes through a channel, which might be free space propagation. It might be, I'll pass this around shortly, it might be this. What do you think this is? It's fiber optic cable, right? Single mode fiber optic cable. Or this twisted pair stuff like I'm connected to right now. Then you have a demodulator or a receiver, which I've got, sitting over here. And then some output transducer. It might be a speaker if it's an analog communications means, or some processing device to decode with. So this was my introduction, but I did more introductions already, but this is the rest of the material then. So I'm going to give you some perspective on where this course fits in, the bigger picture of the undergraduate and graduate curriculum. We'll look more at the syllabus. We'll talk about policies, which I've already mentioned, and then we'll see if we get a chance to get into some of the overview for the course, talk more about software tools, and then I've got this down in here, the COM2 course, which follows this, which is only taught every other year. I just taught COM2 this past fall. But if some of you graduate students or even seniors are going to be here next fall and you really want to do COM2, the videos are there. I've got the material. I mean, it could be done as a self-paced learning type thing using the videos. Dr. Plett and I are probably the only two that have pioneered that sort of approach, but he does that with his controls courses, and I've done it to a limited extent with my classes. I mean, the videos are out there, but you have to be motivated to want to do something on your own. It's more than an independent study, but it's less than a regular lecture because you got to be diligent about doing things. So this is a picture that maybe you've never seen before. Dr. Plett actually put this together quite a few years ago, but this is a top view of the entire undergraduate curriculum for electrical engineers. So you can see that comm systems is over here underneath on the elective side of things. And it fits together after you've had circuits and systems 2. And it folds down into comm systems 2 if you want it to. You can go off and take the lab, which I'll be talking about some here too, how this is very tightly coupled to the lab, which is offered tomorrow afternoon. And I understand that there's 12 of you that are in the lab, but maybe more. I'm interested in as many people that are interested in taking it, because to me, I'm a hands-on type of person. I learn a lot by doing things hands-on, and sometimes the only way you can learn theory is to see something practical and then kind of go back to the math side and say, now I'm motivated to understand the math rather than just be blown away by the math because I've seen something really happen. And the computer simulation projects I'm going to have you do also have that same intention, to try to make the math come more alive rather than just sit there and frustrate you a lot. I can't make you remember calculus like you wished you could remember it, let's say, for example, because some of you maybe haven't had calculus for a long time and it's just a little bit fuzzy. But we can try to pull it out and get you more excited about it. Everything else on here is just the rest of the curriculum in terms of electives and courses that fit together into signals and systems and so on. If you are taking a communications lab, it fits the best if you're taking the electronics 2 lab at this time, but if at least having some lab experience with oscilloscopes in particular, because you get introduced to the spectrum analyzer, which is a much more expensive instrument than an oscilloscope, and that's very integral to the lab as well. For those of you that are graduate students in the class, this is a different picture. This just shows you how, by taking COM 1, you're fitting into communications and signal processing coursework at the graduate level. Right now there's myself and Dr. Harrison, who just started last fall teaching for us. We're the 2 faculty members in the communications and signal processing area. So COM 1, like I've already said, flows down from signals and systems. It doesn't require probability and statistics. It kind of just has a Fourier analysis background from Signals and Systems 2 that you need to have. And it's always offered, in the spring, which is where we're at right now. And then COM 2 is offered in the even fall, so it won't be offered regularly until fall 2014. But you can always, a course that Dr. Harrison, because he's a coding theory and security, it's not quite security, what's the right word? Trying to think. Cryptography. Coding and cryptography are some of his specialty areas. He's probably going to be offering an information theory and coding class next fall. Now, there's a little bit of that embedded in COM Systems 2, but it's just something to think about. Real-time DSP is offered every spring, and that's pretty popular for graduate students to take. It's very hands-on. My bag has got some of the hardware I'm going to be running in the classroom downstairs when I move there later. So that's a very fun class to take. If you're an undergraduate still looking for another class, anybody is eligible that's been through 2610 to take that class. You need to have a desire to program microprocessors and program in C in particular. But it's available. I think nobody in here is in that class, though, if I'm remembering right. There are several undergraduates, though, that are taking the class this time. Modern DSP is in the fall, so that can be taken from a Signals and Systems background as long as you've had some probability exposure, too. And then the big class that's offered for me to teach is on Monday nights is the statistical signal processing. It's probably the hardest class to take and the hardest class to teach in this discipline of communications and signal processing. Other classes that are down here, like phase lock loops and synthesizers that show up in communications receivers, that can be offered on demand. Wireless networking, we used to offer that until Dr. Price left, and Dr. Harrison may introduce that class, but his main area is information theory and coding, so he's going to launch his graduate specialty class in that area. What makes 5615 so complicated and difficult to teach is it actually encompasses a little bit of those 4 classes. We used to teach all 4 of those classes as standalone classes when we had a bigger program, and then when we downsized a number of years ago, I took on the challenge of trying to replace those 4 classes with just 1 class, which looks like, you must be crazy to try to do that, but that's where it's at right now. Spread spectrum is popular as well as a special topics because it relates to military communications heavily. So people sometimes demand to take that as an independent study in the summer. And the other ones are up there. Optical comm, I've taught that a couple of times, and satellite comm. Well, that's pretty much what I work in. And wireless and mobile is a little bit of that is inside COM 2. If you are a graduate student and you're just in the program and don't know where to go, you can talk to me after class sometime about what you might take next fall, let's say, for advising. Okay, here's the syllabus, which I've handed out to you. It tells you how to get to the website, tells you my email. It tells you the approximate office hours that I've set up for this class, but you know how to get to that big graphic, so you can always take a look at that. Optional software is to have your own copy of MATLAB with Simulink running on your own laptop. It's $100. It's less than a textbook now, right? Dr. Zemer, who is my dissertation advisor and who is one of the half authors of the book, has got the 7th edition of the book in preparation right now. He's retired, but he's still working on book writing. I asked him again just recently when it would be out, and he said it's not due to be out until a year from now. So don't hold your breath waiting for the 7th edition. You need to have the 6th edition now. So MATLAB runs all over the campus. It runs on the remote computing systems. So it's pretty much available, but if you're like me, having your own copy is just a lot more fun. I mean, it's there when you need it. You don't rely on networking of any kind. Okay, grading policies. You know, like I said earlier, this is what I'm going to go with for starters, the graded short quizzes. If I sense, you know, I could do something different, I would make up my own homework assignment. But because I'm still heavily involved with editing my book and the heavy load of classes that I have, I just don't want to venture down the path of, you know, if I do it half-baked, then it'll blow up in my face. I'll write problems that either you can't work or are too easy or whatever, and it just, you know. I may get a really nice grader, though, somebody that will help me out, in which case then maybe I could explore that opportunity. Computer projects, there'll be 2 of them worth 20%. They will be team-based. And for those of you graduate students that say you don't know anybody and you can't work together, I can only say you can network. We'll maybe have a little icebreaker here on Thursday to have everybody introduce themselves. It's not something I generally do in an undergraduate class, but because there are graduate students in here, I have like an icebreaker where everybody says why they're in the class and kind of if they want to talk about, you know, what motivated them to come take the class. And that opens the door for networking then usually. And you undergraduates might want to listen when they say something because they might have some ideas on employment too. Right now employment scene is pretty good. I'm going to be visiting a company next Monday that wants people in the comms area to get started young because they want to get your security clearance started early. I'll know more after next Monday, but the opportunities are pretty good right now. Now, of course, with budget issues and spending on defense and so on, you just never know, right? Something could be cut and then things could slow down a whole lot. We'll have 2-hour exams, and then we'll have a final exam. And the second computer project will be due right at the end of the semester, so it's not unheard of for me to play some games with these numbers. I mean, I'll abide by what I've set up right here, but I might, at the end, say if each computer project is 10%, I might make the final computer project worth 15% and take the final down to 25%. And the way I'll do that is I'll do it with an optimization in my spreadsheet. I'll use whatever score gives you the best overall average. And you've probably had that done by somebody else in the past, but it's just a little incentive because I realize if you work hard on a project at the end of the semester, you're kind of in double jeopardy because you also have to study hard for the final. So I want you to not feel like you're burning the candle heavily at both ends, but you're getting the ability to say, if I have a bad day in one thing, I can compensate in another area. The topics that we cover out of the book is just a fraction of the entire book. The linear systems review and some new topics that aren't things that you've already studied. So we'll look at autocorrelation function and power spectrum. We'll also spend some time with the Hilbert transform. Probably won't do anything with sampling theory. We'll go through it, but it's something that you've seen like in 2610, and you've seen it again in 3205, I believe. Probably won't do generalized Fourier series, although it's in the book and it's in the notes. It's a neat topic, but based on my experience, I'm not sure I'm going to want to take the time to go through it. I bet most of you took linear algebra as your math elective, though. Is that true? It's closely related to linear algebra, and it kind of ties some ideas from that together with ordinary Fourier series. And my guess is, if there's two things of signals and systems that you hate the most, it is Fourier series and Fourier transform. You can write that on my survey. You can tell me that. Two hardest chapters for me to edit so far in my book, too, because my technical editors, which are, one's a professor and the other one's an engineer from the Mayo Clinic, who was one of my graduate students many years ago. That's where they raked me over the coals the most, was on that material. That and convolution. Convolution is not a whole lot. Convolution integral, remember doing that? It's a nightmare, right? So they want to make sure that the dummies book is dummy proof, I guess, but I just don't think you can be a dummy and learn signals and systems, but it's a term, right? Chapter 3 is where we get into the modulation theory. So we have analog modulation schemes primarily covered in Chapter 3, which are the legacy schemes, but they're still out there, they're still valuable, they're still carrying vital information, and they serve as the starting point. We will have some digital talked about. I do have a Chapter 4, which is a hybrid of what's in Chapter 4 of the book and then some additional notes. I didn't get a chance to really go through that last spring. I don't know what will happen this spring. But we will for sure get into this chapter, which is actually Appendix A, Noise Sources and Calculations. This is more of a physical thing, but it's something that hampers all communication systems, and that is noise. Noise is actually modeled probabilistically using random processes and random variables. But the modeling of it, the noise, say the excess noise across the terminals of a resistor when it's at room temperature, that's the type of modeling, so you can understand noise figure and a link budget for a system. And Dr. Song might do that a little bit in some of her classes, but it kind of falls in a crack between, what might be in E&M and would be in comm systems, because we share that space. Propagation and wave propagation is also something that falls sort of in the crack a little bit too. Communications engineers want to understand propagation theory, and I'll be getting into that in this intro chapter, because our communications waveforms rely on it, and we have to design our systems to account for that. If there's a heavy thunder shower going on and a SATCOM link is going through that thunder shower, do you think it goes through unimpaired? It doesn't. So the system has to be designed to tolerate things like that. Any questions on the syllabus? Okay, if I do have papers due, I want them due at the start of class. And if there's issues with that, like you're on business travel or some similar activities, when I say similar, I mean the excuse I didn't feel like coming to class is not a good one. It has to be more legitimate. It could be my babysitter didn't show up today, or my car stalled, I was in an accident. I have email on my cell phone, so I can at least get that to give me a heads up. It'd be nice to know if you're on business travel, though, well in advance, so I'm just not wondering where you're at, because I want to be able to post solutions. I want to be able to post whatever it is that might be related to what you're turning in as soon as possible, and I'll need to know what the status is of the papers that I'm expecting. Under extenuating circumstances, I will still post solutions, but then I'm going to put you on a high honor code to not go looking at anything. But basically, the idea is give me the heads up before rather than after, because after is just not a good thing. It's kind of like it's an afterthought. So I realize you can't always do that if you had a misfortune on the way to class. The grading system is a straight scale and then curving below thresholds as needed. And you kind of see how that unfolds as the semester rolls out. I will give you updates with histograms to let you see how the class averages are going. It's probably one thing where Blackboard, I think, excels at. You can have that all automated by entering the data in, but I do it in a spreadsheet, and I can get histograms generated fairly easily. You just can't go see your grade at any hour of the day. I have two sons that are in college, and I know they're at different schools, but yeah, they can find out from most of their professors. Maybe by the time I retire, they'll be insisting that we do that, but right now they're not insisting that we do that. Already talked about PDFs and things that I'll be putting up, so we'll get into that. Okay, what's the connection with the lab? Like I said, it's very tightly coupled, and it's a hardware experience that has theory touching right up against practice or measurements. Because when I first started teaching here, I was challenged with creating the lab. I got involved with that early on, and now we're in the second generation lab, one that was redeveloped by me over the past couple of years. Les Camp is teaching the lab for me. He's extremely great at teaching the lab. I mean, he's helped build some of my test modules or receiver modules that you use in the lab experiments. He knows what's going on with, it's sort of a hybrid of RF circuits and baseband circuits is what you get to do in the lab experiments. These are the main topics. These last two labs still haven't been written yet, but the first 5 are in place. We're going to take a quick little tour over there just since I've got the web browser running. Since 12 of you are in there, I'll probably come to lab tomorrow afternoon too, just to see who shows up and kind of give some overview. This is the lab's web page, and these labs I hope to get updated. Les is going to give me some feedback on fixing some of the text and things in them. I haven't seen it yet though. You're also going to use an mbed microcontroller in one of the labs. Has anybody ever played with an mbed? Does anybody know what an mbed is? Do you know what an Arduino is? Okay. You know what an MSP430 is though, right? Okay. So the MSP430 is kind of way over here on the spectrum of, it's very down-to-earth programming in C or assembly. I personally think you spend too much time on assembly programming, and I'm trying to get that resolved, but C programming is more straightforward for sure than assembly, but they have their place. But then you come over the other end of the spectrum and you have the Arduino, which is all C and C++ programming. It's just really a breeze to rapidly prototype things. It's not a super powerful microcontroller, but it's very capable, and the development environment is so-so, but it's got a powerful set of libraries. Then you come back sort of more to the middle, and the mbed is an ARM Cortex processor, and ARM processors are in virtually every cell phone today. It's a 32-bit processor that runs with a 100 megahertz clock. So it's quite a bit more of a microcontroller than, say, the Arduino is, and then the MSP430 comes from a huge portfolio of microcontrollers from TI, but when you have an easier programming environment, you don't necessarily make the most of all your clock cycles. So some of your MIPS get wasted in the ease of programming. But by having more horsepower in the microcontroller, then you can get more done with easier programming. And that's kind of what the mbed is. And the mbed, what's really cool about it is that the tools for it are in the cloud. So you just plug it in like a thumb drive, and you set up an account, and your IDE pops up in a web browser, and you write all your code and debug it right in the cloud, and then when you get ready to run it on the processor, you build it. It ships it right back down to that device like it's a thumb drive, and it drops it in there, and you hit the reset button on the top of the mbed, and it loads that latest binary onto your mbed, and it runs. So and they sell for, I think it's about $50 a piece. The Arduinos are about 25, And the MSP 430 launch pad, I was the person that kind of pushed that out into the program. Originally were $4.30 a piece. That's what TI set the price at. I don't know if you knew that or not, but that's the launch pad kit. When it came out, was TI's way of trying to fill the market with them. Does anybody know why they would do that? Because I don't think they make money selling the launch pad at $4.30.
You get industry, you want to program with what you're accustomed to.
Right. And you guys are young and impressionable, so they put something in your hands, and you're going to get hooked on it, just like MATLAB and the other things that you've been exposed to. Don't feel scared, though. They're not going to swallow you up, but you are getting exposure to things that will make, you know, they know how to operate. It's not a new thing. It's been going on for forever. It's not an evil plot, I guess is what I'm saying. So, for example, well, rather than showing you an example, well, maybe I should. I won't. I didn't have enough hands to carry one of the modules down with me. Those of you that come to the lab tomorrow night will get to see them. If you're interested in just exploring the lab as an option, it meets tomorrow, I think, at, what time is it again? 4:45 to 7:05 is when it meets tomorrow. And graduate students have been known to take it too. It's a little bit more complicated for you to have to take it, but some graduate students really want to take it, and they have taken it because they haven't had that experience of having the hands-on part before. You got a question? No? Probably the biggest thing is the spectrum analyzer that you get introduced to. You also use a vector network analyzer, and you'll exercise that to do magnitude, phase, and group delay measurements of at least one filter circuit, but mostly for spectrum analysis. You know, the Fourier transform takes you to the frequency domain. And what's fun about the frequency domain when you had it in 3205? Can you think of one fun thing from the frequency domain?
How to run a differential.
How to what?
Like instead of doing differentials,
Okay, I mean as in a high-pass filter that acts like a differentiator, is that what you're saying? Okay, never mind. Well, I'm being facetious. There's not really a whole lot of point in the Fourier transform unless you see an application for it, and this is the class where it has its applications. So that pain and suffering doesn't have a payoff until you come and take a class like this. Mostly. Now you can be a high-speed digital designer and be caring about the spectrum because maybe there's some issues with leakage off of your substrate, and you're using a spectrum analyzer to sniff around and see what harmonics of the clock and other things are getting off your board, and your PCB design maybe needs to be modified because you've got some problems. So there's peripheral things, mostly electromagnetic compatibility and some other issues, but in communications systems, the spectrum is vital. The high school open house last week, I went through that last Thursday. There were a couple people. Was anybody? I can't remember who I talked to. Nobody from that's here now saw my demo. I had a spectrum analyzer, but I guess those were younger students. When you take exams, you'll need to have a calculator. But when you work projects or homework problems, I'll be encouraging you to use MATLAB. And at times I use Mathematica just because I like its symbolic capability.
Question.
These other things, yeah.
So you're going to be doing Mathematica demos. Are we going to be needing to use Mathematica for homework assignments?
I leave that up to you. If you have the bandwidth, in other words, if you have the time, learning something about a symbolic tool is handy. Some of you, have any of you ever used Wolfram Alpha?
Yeah.
Okay. See, that was another thing that I got in a bad way with my editors at the Dummies book thing. I'm using Maxima, which is like an open source version of Mathematica. And Python has a symbolic capability too, with a package called, I guess the name doesn't matter, PySym is what it's called. Everything's got py in it for Python, but Py symbolic, or SymPy, that's what it is, SymPy. And I argued with my editor recently saying most students will probably just opt to use Wolfram Alpha, which is out there on the internet, but I'm just giving them options to see things. And my editors were saying, keep it all within Python. Well, I have a problem with that myself, because if you bought MATLAB, you know it has a symbolic capability too, but I find it to be somewhat difficult to use. I've never really gotten into using its symbolic engine, and I've preferred to use Mathematica's, or Alpha is just, you know, the web version of Mathematica. Really what it comes down to with computer tools is, I think a good engineer has to be what I call myself, and that's a software connoisseur. I mean, it sounds kind of bizarre, but you pick the tools that best suit the problem at hand. You don't try to make, you know, a square peg go into a round hole, etc. type of thing. You kind of go with the tools. Now, if your employer says you can only have this one tool, you can't have another one, we won't buy you another one, then you're going to just have to adapt. But as I started to work at Emergent, doing satellite systems modeling, comm systems modeling, they said, we're not going to buy you MATLAB. And I'm like, okay, what am I going to use? So I started using Octave, which is free. It has the exact syntax as MATLAB. It doesn't have as many toolboxes, but I had a lot of homemade stuff, and then I found other things. So Octave is very nice. It's available cross-platform. Python then has the better graphics packages, but the two work kind of hand in hand a little bit. So that's how I got into this stuff. And then when I saw how well Python worked, and the fact that these companies use it for other areas, that's kind of how I got hooked into it. And then Maxima more recently. If we have to do system simulation, we could use MATLAB Simulink, we could use Agilent ADS. I generally just prefer to write simulations in what I call M code, which would be just the native MATLAB programming language, which you got exposed to when you took 2610. Now in the lab, though, we do use ADS a lot. I have a lot of Agilent ADS software to download that you'll use in the lab, and you'll use ADS right there in the lab, because I've got things built up to model very closely what the lab equipment does in the simulation environment, and you can use it as a cross-check on measurements, and it works really, really well. If you've never used Agilent, I've got the scoop on my website for the lab, a tutorial you can walk through, and then, like I said, the projects that you can download and set up and use, with a lot of stuff pre-built for the lab. If you're not taking the lab, don't sweat the details about ADS, but I definitely use it. How many of you, just out of curiosity, have used ADS somewhere? I know you've used it a lot. Your whole thesis was based on it, but nobody else has used it at all? Okay. It's a pretty user-friendly environment, but it is, talk about a monster. It is a huge piece of software. It is just massive. It's one of these things that you can run on the remote access systems only, except we have it in the labs too. For me to run it on my computer here, I have to plug in a little USB dongle to get to act as a license to run it. But in the lab, it's readily available, and that's where you'll use it the most, is in the lab. Okay, what is COM2? Let's see. I guess I should look at the clock. Where's the clock in here? Good. When I start buzzing along with excitement in my mind, at least, the time always goes just like that, and it's gone. For me, at least. For you, it's probably gone at a snail's pace, but for me, it goes by fast. COM2 follows this class, and its focus is digital communications. So if you come back to take that class, if you're a graduate student in particular, or if you graduate and decide you're going to work for a company that does this type of stuff, you might want to come back and take it. You get an introduction to random signals. Then we work with digital modulation schemes, of which get introduced in this class if I get into Chapter 4. Some more about mobile radio and satellite communications, and then coding theory. The course is pretty fresh in my mind. It's a good class, actually. I had somebody from University of New Mexico who's teaching that class who begged me for my notes for the class, so I actually let him, under provisions, have access to my notes for his class. And surprisingly enough, it's a special topics class down there. I would think at a bigger school like University of New Mexico, that's their flagship for the whole state of New Mexico, that they would teach it more regularly. But this guy is an adjunct professor teaching out of the same book. That's what brought him to me, is he found my notes because I was using the same book that he's using. Okay, so what is the baseline of this whole course? Is somewhere in the introductory chapter it says, Theory of Systems for the Conveyance of Information. It sounds sophisticated, and it certainly is more impressive sounding than just saying communications, because when I was first a professor teaching here many years ago, back in 1984, long time ago, right? I had the school paper come and interview me about what do I do, and I said, well, I teach communications. And of course, what do you think a newspaper type reporter person is studying? They're studying communications. So I was like, okay, I need to set this straight. What is the difference between their communications and my communications? And it was a little bit challenging, but I think it came out in the article okay because I made such a big deal about it. So they're not the same thing, and that's something you got to explain to your friends when you say you're taking communications theory. It's a whole different thing. It's far more technical, and if you were like me when I was in school, I would rather take this class than I would take a communications class. I don't know how you feel about the subject, but it's important, though, obviously, but for an engineer, this is more important. So communication systems have to deal with uncertainty, noise, and interference. That's one of the things that sets comm systems apart from other types of system study that go on. Controls has some of these same issues, but communications is constantly being bombarded with noise and interference. Systems have to interoperate. Systems have to operate with the minimal amount of power, so that brings signal levels down close to the noise floor, which means you have to do optimization and filtering. You can't get by always by blasting your signal through. Now, in certain applications, yeah, you just blast away because you know the enemy is going to be blasting away too, and you just try to overcome them by sheer power and might. But usually, in a military comm system, you use some intelligent signal designs and things to make your signal still survive interference and such. This is a first course, so we dwell essentially always on deterministic signal modeling. But in the simulation projects, I open the door to have interference and noise because I want you to play with some frameworks where you see what it's really like. Everybody in here has a cell phone. You know calls aren't always perfect. You tune in radio stations as you're driving across the country. You know those fade out, and you have to tune in a new one. Unless you have satellite radio like I've had for quite a number of years. That's what's really great about it. It doesn't disappear like that. So you're aware of that fact, and to be able to see a little bit of that, I think, is important. In the lab experiments, you'll see a little bit of that too. You'll see that it's harder, for example, to multiply two signals together than you might think. That's a fundamental building block in a communication system, being able to multiply signals, but a hardware block that does that. An analog multiplier at a high frequency is actually pretty challenging. So Dr. Ziemer has in the first chapter some timeline issue or items, and I've just got a few of them in here. For example, in the COM lab you'll be working with a super heterodyne radio receiver. I've actually got two different designs, a single conversion and a dual conversion, of which I'll bring one of those two in on Thursday. But it was back in 1918 that Armstrong, one of the pioneers of radio, actually perfected the super heterodyne principle. Now I'm saying that because I'm going to mention something that just maybe is something you've heard of. Has anybody ever played with a crystal radio younger in their life? Okay. You have any fond memories of that?
Not particularly.
Did it work?
Yes.
Okay, that's the important thing. And it worked with what?
Small little.
No batteries, right?
The one I used had batteries.
Really?
Yeah.
Well, the ones I played with just have a diode and a capacitor and an inductor and a long wire and then an earphone. You can make an AM radio with just, some parts like that. But it doesn't work very well. It has poor selectivity problems. You tend to get all the stations mashed together because you can't select one out. And that's what the super heterodyne principle allowed, and that's what Armstrong came up with in 1918. Seems like a long time ago, like about 100 years ago. Right? I keep thinking about that as I look at the calendar, saying we're in these teens years of this new century, and the years, to me, are flying by, and you're thinking, when you studied history, you think about 1918 like that. Well, we're just offset by 100 years now, so we're reliving those teens years of this century. The older you get, the more you think about getting old, I guess, is what it comes down to. You're not thinking about that now because you're young, but you start thinking about that eventually. Okay, World War II, radar was a big deal. Transistor in 1948. Laser demonstrated in 1960. Fiber optic communications in 1977. My first job was at Motorola Government Electronics down in Scottsdale, Arizona. It's now a division of General Dynamics, but I actually worked on that program right there. It was called the NASA 3020 gigahertz program, and rather than being a satellite that just is what's called bent pipe, or signals go up and then a transponder just sends them back down again, this was a design to actually have processing and effectively a switchboard in the sky is what they called it. And I think NASA got involved with it because other countries in the world were talking about doing the same thing. I think Japan was at the time. And you know how the United States wants to be the leader in every and anything, if financially possible. So I think NASA jumped in saying we got to do something. Maybe the president told NASA, you got to make a switchboard in the sky satellite system. GPS came along in the 90s. That was where I worked at Motorola. There was a lot of work done on GPS in those days that I was there. Cell phones also in the 90s. Smartphones came around in the 2000s. And last year when I updated this, I put in LTE, which stands for long-term evolution, or fourth generation cellular, is rolling out in 2011 and 2012. And I was at the AT&T phone store over the weekend, and I was thinking about, do I want to get an iPhone 5 because it has LTE, and I thought surely there's got to be some LTE cell sites in Colorado Springs by now. There aren't any. They told me it won't be till this summer. They said if I go north towards Denver and get up to I-4 or E470, C470, that's where I'll hit my first site. And I thought, that's that's pretty dismal. I mean, we have all this technology in the phones, but we don't have the infrastructure to cash in on it quite yet. But those of you that follow this stuff probably more closely than I do, you have to understand it's very, very expensive. The hardware that goes into a base station for a cell site is very expensive, and to just rip it out and put new stuff in takes a lot of money collected from all of us users. They need a lot of money because they want to make money, right? They have to be profitable. So hopefully that will become more of a reality here, and as the economy, if it can pick back up stronger, I'm sure cell sites will get replaced. Okay, we've already talked about a block diagram, so I think I'll just move on from the block diagram. Basically, we're looking at information flow in one form or another, and this is a very generic block diagram. It doesn't say whether it's an analog, speech, music, or digital information flowing through the systems, and that's left vague like that on purpose. So the next thing I'm going to talk about briefly is the channel. So the channel is one of many forms. Probably the most dominant type of channel in that block diagram is the straight free space propagation channel, or EM wave propagation. And this is a picture that appears in the book. It's just showing you three dominant forms of free space propagation. One type is SATCOM, which is trans-ionosphere, meaning that signals are passing through the ionosphere. In that ionosphere, if you're good at remembering physics and what ions do to waves that try to pass through a field, they can either look like a screen that nothing gets through, a screen that's so dense that nothing gets through, or it can look like, it's wide, like an open window. I guess the analogy there is your microwave oven. Your microwave oven has a screen on it, right? Light passes through, which is tiny wavelengths, but the microwaves don't because it looks like a solid piece of metal to them. Question?
So is that polarized? Is that why? Or is it the reason it passes sometimes and other times it doesn't?
Well, it depends on the frequency and the spacing of the ionized layer. I'd have to brush up on my propagation theory, unless somebody else in here wants to explain. You might remember exactly from, I'm not putting you on the spot, but you've had more recent classes. Anybody's been in one of Dr. Song's classes recently?
Oh, we're in it right now. We'll find out later.
Okay. I know I can look it up. I just didn't go review it. But this is a crossover region for comms people. There's great propagation theory books. All I know is the simple model is just to say the ions act like forming a metal-like screen. So signals above a certain frequency will pass through the ionosphere, and those that are below, say 100 megahertz, are not going to get through the ionosphere. And of course the ionosphere moves up and down, so it moves up and down between when the sun is out and when the sun goes down. Now this is something that you can think about from a geometry standpoint, though. What happens when the sun goes down? If you listen to AM talk radio, does anybody ever listen to talk radio? What happens at night, though, if you turn your AM radio on? Have you ever done that in your car?
It doesn't work.
It doesn't work?
It's all fuzzy. A lot of it's usually.
You should be able to get stations from all over the country, though. Pardon me?
What's called ducting.
Yeah, it's due to the ionosphere dropping, and then that's what I was going to try to say. If this layer was to come down, then a wave that bounces up, and angle of incidence equals angle of reflection, right? Then it's going to go a lot further than if it's up higher. It tends to just go up and come right back down again in the locale. So the reason why it might appear that AM radio doesn't work at night is because of this ducting, or this lowering of the ionosphere means that radio waves in low frequencies travel a huge distance. So the reuse of all of the spectrum, AM radio stations in Chicago and New York and Los Angeles all share the same AM broadcast band for their talk radio. But if they are all going to clobber each other at night because of the fact that waves can travel so far, that's no good, right? So the FCC, Federal Communications Commission, says that only certain stations can stay on after sunset for that reason. And they're the powerful stations that are heard around the country with the right antenna. So you might want to try it sometime. Just tune around a little bit. You'll probably hear a station from Chicago and New York, or maybe Los Angeles, as an example. I mean, Colorado Springs, I don't think ranks up there as having any stations. We have stations that have certain rights to stay on after sunset, but they still have to reduce their power, I believe, so they don't interfere. It's actually, amateur radio. Does anybody do amateur radio? Have you heard of amateur radio? My father did that, and that's probably why I got into electrical engineering, because he had radios and the workbench with the test equipment, and we just surrounded by electronics pretty much growing up. So that's a little bit about that propagation. But then the really low frequencies also tend to hog the curvature of the Earth. So that's a ground wave propagation mode. So that's another thing that's going on in there. But the things in between that can't get through the ionosphere and don't curve with the Earth's surface are what we call line of sight. Like broadcast FM is line of sight. It's in what's called VHF band. And it just shoots straight. It doesn't reflect, and it doesn't curve. So as you get beyond a certain radius, FM radio stations just fade out because they don't follow the curvature, and of course the power is also limited because, again, they have to be shared. If you've come over Monument Hill listening to a Denver station, you know that there might be a brief moment where you're hearing first the Denver station, then it fuzzes out, and then it captures the Colorado Springs station off of Cheyenne Mountain. Because when you come over Monument Hill, you pretty much have a line of sight directly to what's the mountain down here that has the antenna farm on it, as I call it? Cheyenne Mountain. That's where all our transmitters are. So there's a moment where you're getting... Has anybody experienced that? But it flips. It might flip back and forth a couple of times, but then it pretty much goes away. I often wonder if there's somebody that lives right up in that area that has really, crummy reception because they can't get a strong signal of each because the two are kind of colliding right over their rooftop. Okay, I think what I'm going to do is I'm going to have you take the little survey right now. This is something I did last year. It was fun, and I'll report the results. I'm going to stop the video at this point as well.